So hello everyone. At this week we are meeting at the University TV for the System Analysis and Design course. At this week we're going to cover a subject called Manufacturing Systems. So actually we just have the subject, the manufacturing system, in different lectures of our industrial engineering department. As a systematic view and from the manufacturing view in the system analysis and design course, today we're gonna look at the types of the manufacturing systems, and also we're going to analyze the characteristic features of the different manufacturing systems that we usually face in the organizations, basically in the manufacturing organizations. So let's firstly define with the exploratory definitions of the manufacturing systems. So the first definition here we have is the manufacturing system is a collection of integrated equipments and human resources whose function is to perform one or more processing and or assembly operations on a raw material, part or set of parts. At the second explanation, a set of operations performed on material which brings them closer to the desired final form. So when we look at the the shape given here, as an input, the raw materials are just entering the manufacturing system, and there is a black box that we call as the manufacturing system, and the process is just going on under this system, and the products just come out as an output for the system, and some kind of support elements that we have, for example, equipment, tools, fixtures, labor, and the energy, which are supporting the manufacturing system. And also, as an output, sometimes we can have some scrap and waste of materials that we do not want in terms of the efficiency perspective. So, as we just started from the beginning of the course at the semester, the system view of the system view that we can consider for the manufacturing system can be just viewed as given here, as inputs just enter the system, and the black box is just running out under the system, and the products as an output, or the other outputs that just come out of the system. So all operations here in this manufacturing system are concerned with the input, transformation, and output process. Here we have the inputs that we can say man, material, machines, and the drawings, and etc. That we have these kind of resources that we define in operations management also. And the transformation that we can define, that we can give as an example as operations, material handling, procurement, and etc. And the output, it can be final goods and the services that we see out of the system. So therefore, the combination of operations and the activities mentioned before employed to create goods or services is termed as manufacturing system. So all the materials and the equipments that we just put to the system and take the output as a product or the service named as the manufacturing systems. So when we look at the examples of the manufacturing systems, we have slightly different types of the manufacturing system, such as single station cells, machine clusters, manual assembly lines, automated transfer lines, automated assembly systems, and flexible manufacturing system. Since we have the different types of the manufacturing system in an organization, we have some kind of criteria, slightly the considerable criteria that we should consider to find the optimum and the best manufacturing system that we should apply in our company, such as these criteria can be listed as the effect of volume, capacity of plant, flexibility, lead time, efficiency, and the environment. So these criteria can be listed as important, factors that affect to reach our final product in a required level and to be cost effective. So how about the components of the manufacturing system? So when we look at the components of the manufacturing system, as we just place the manufacturing system in the center, we have its components such as the information, which is highly related with the computer system that we establish in our organization, and the operations that we just run with the machines inside the organization, and the humans, which are our intellectual capital that we hire and that we employ in our organization, and the physical systems, which are highly related with the material handling system that we want materials to be handled to the right place in the right time and to the available position. So let's firstly have a look at the production machines as a component of manufacturing system. Here we have the three different production machines that we encounter in many organizations. The first type is the manually operated, and the second one is the semi-automated machines, and the third one is the fully automated machines. Let's get into detail with this type of machines. So the manually operated machines, as you can see on the shape, the work cycle is 100% carried out by the worker as a manually. Okay, here you see the machine is just taking care of the whole process by loading and the unloading at the end, and the worker is just controlling the machine by manually from beginning till the end. And how about the semi-automated machine? As you can see, the work cycle is just carried out by the worker and the program itself. Okay, so the worker and the program control are just taking place for the for the machine to be just complete the process. So the most of the time, the typical worker tasks include loading and unloading parts, and the rest of the tasks are carried out by the machine and the program itself. And how about the fully automated machine? As you can see, the work cycle is 100% carried out by the program itself, and as you can see, the worker just paid periodic attention on the fully automated machine, and the program itself just taking care of the process. And if there is any kind of failure of the machine or any kind of break situation happen in the machine, just worker is just taking place to just fix the machine and to move the process to the forward steps. And the material handling steps, which are also so important for the manufacturing as a the part of the manufacturing system. In most manufacturing systems that process or assemble discrete parts and products, the following material handling functions must be provided, such as loading work units at each station, positioning work units at each station, unloading work units at each station, transporting work units between stations in multi-station systems, and the temporary storage of work units should be carried out by the material handling system as a part of the manufacturing system in an organization. And we have the two different types of the work transport between the station, such as the fixed routing and the variable routing. The fixed routing can be common example of this work transfer between stations, as we see in many organizations. And the variable routing, the work units are moved through a variety of different station sequences. So most job shops exemplify this category. So when we look at the process of the fixed routing and the variable routing, the starting units for the fixed routing just enters to the system. As we can see, the arrows show the workflow between this workstation. Okay, so the workflow just passes to other workstation as required in the process, and at the end we just have the completed work units. And so when we just take a look at the variable routing shape at the second part, here we have the starting work units, and the workflow just pass to different types of the workstations as opposed to the fixed routing, and the flow of the work is just going on to complete the work units at the end. Okay. So how about the computer control systems? So the typical computer functions in manufacturing systems can be listed as given here. So for example, the first function can be to communicate instruction to workers, and the download part programs, control material handling system, schedule production, failure diagnosis, safety monitoring, quality control, and lastly operations management. And here as a last component of the manufacturing system given here is the intellectual capital, or the human resources that we just hire in our organizations. So the responsibility or the function for the human resources in the manufacturing system is to operate and manage the system or process, and they required either full-time or periodically to keep the system running. Humans refers to all personnel, operators and vendors at the same time. In context of manufacturing system, humans perform some or all of the value-added work that is accomplished on the parts or products, and performing either manual work on it or by controlling the machines. In fully automated machine, direct labor is still needed. And as an example, loading or unloading parts and the changing tools, resharpening tools, or etc. That we can give as an example function of the human resources in manufacturing system. So here we have the types of manufacturing system as we just classified into two different, let's say two different sections, such as intermittent, which is discontinuous production, and the continuous production. Under the discontinuous or the intermittent production, we have the project production that we also covered in the project management course, and the jobbing production and the batch production. On the other side, under the continuous production, we have the mass flow production and the process production. So let's take a look at the different types of the manufacturing system that we have in our organization. So yes, here we have one very critical representation that shows the difference between the continuous manufacturing systems and the intermittent manufacturing systems. In terms of the variety, when you look at the continuous manufacturing system, the variety is too low for the flow production and the mass production. But when you just go to the intermittent, discontinuous type of manufacturing system, as we just include batch production, job order, and the project production, the variety just becomes high. And when you just take a look at the uniformity perspective for the continuous production, the uniformity is high. But when you look at the intermittent intermittent manufacturing or the intermittent production types, the uniformity is too low for these three different types of intermittent or three types of production system. So here is the comparison between the continuous and the intermittent manufacturing systems with respect to material handling and the labor. So the unskilled as well as small team of specialized labor force are just placed in the continuous type of manufacturing system, and at the discontinuous, highly skilled labor force are needed for the intermittent. And the mechanized material handling is very needed for the continuous type of manufacturing system, and on the other side, not feasible to employ mechanized handling at the intermittent. And the material handling cost is less in the continuous production system or the continuous manufacturing system. And at the other side, in the intermittent type, material handling cost is higher since we are dealing the variety of materials and the equipments. And the investment in inventory is higher in the continuous type of manufacturing system, and the need for inventory is minimized at the intermittent manufacturing system. So on the basis of machinery, when we take a look at the machinery perspective, for the continuous, specific machinery is needed, and the intermittent generalized machinery is needed, which is more fitting to flexible manufacturing type also. And the permanent machine setup is needed for the continuous, and the frequent change in machine setup for the intermittent. And at the continuous side of the manufacturing system with respect to machine, the duplication of machines can be seen at the continuous manufacturing system, and the intermittent, less machines required for the intermittent manufacturing system. And with respect to output produced, we can say the product that we just come out, that we just see it as a output of the manufacturing system. At the continuous side, few standard products in large quantities, and at the intermittent side, we can see wide range of products in small quantities. So at the continuous side, the output on the basis of anticipation of demand, and the intermittent side, output according to order received. So here we just listed the characteristic features of the continuous production system and the intermittent production system as we just encounter in the manufacturing system. The first one is the flow type. So in the flow type production system, output cannot be segregated into different units, and the high degree of output can be observed, and the output cannot be measured directly. For example, the production for the flow type production, we can just give an example of power plant. And the mass production, straight line flow of material, output visible as identical units, standardized output produced in large quantities, and also in the mass production we can just encounter some kind of bottleneck problems that we need to solve. So how we can just solve this kind of bottleneck problems is the balancing the production lines. And we can also have kind of machine maintenance and the raw material. So for example, we can just give an example as sugar production. And when we take a look at the intermittent production system, we have the batch production system first of all. As a characteristic feature, a variety of products made in small quantities, and the various products compete for share of machine, and the outputs are aggregated in form of batches, where batches can have similar or dissimilar outputs. We can just give the electrical goods production for the batch production system. And the job order production system does not have its own standard product, but accepts whatever customer orders, and the output identifiable in terms of specific job order, and the material flow is so complex in the job order production system can be given as tailor shop for the job order production system. And for the last one, in the intermittent production system, is the project production system. It uses resources on different projects, and the product remains fixed, and manpower and facilitates put work on it, and the PERT and the CPM, the critical path methodology, can be used for planning and control at this production system. So here is the references that I just benefited while preparing these slides. So for this week we covered the manufacturing systems as a subject, and in this subject we just defined the characteristic features of the manufacturing system, and we just classified the manufacturing systems into two different sections, such as discontinuous or the intermittent systems, production systems, and the continuous production systems. And under these levels we just defined the three different types of intermittent manufacturing or production systems, and we defined the two different types of manufacturing systems under the continuous production. And also we just take a look at the differences between the continuous and the intermittent manufacturing systems as an general, and we just defined when we can use the or how we can just define the criteria that we can find the best manufacturing system that can also fit our organization culture and the organization structure that we just can apply or implement in our organization. So this is it for this subject. Thank you for your participation and watching. See you at the finals. Thank you.